Question number 8, graph these 4 types of functions. So the first one is absolute value function. The second one is a quadratic function. Third one is square root function. And so D is a cubic root function. So B and D are polynomial functions, right? So we want to use a reference graph. So the graph of the simple one, we call reference graph. So we want to use those reference graphs to graph this little bit complicated function, or treating as transformations of the reference graph. So basically we're treating these functions as the transformation of those functions. So let's graph the reference graph in red color, then we graph the transformations in blue color. So let's graph A. So A will have absolute value function, right? So absolute value function, the graph is a V shape. The V shape. If you're not familiar with this, you can use 3 points. You can evaluate f of -1, which is absolute value of -1, which is 1, right? So this gives us a point, -1, comma 1. So let's see, this is -1. So this is 1 on y, right? So that's this point. Then maybe we evaluate f of 0, or absolute value of 0, still 0. So get 0, 0, get the origin. Then we evaluate f of 1. F of 1 is absolute value of 1, which is just 1. So we get a 1, comma 1 point. So we have these 3 points. So we can graph. So this is absolute value of x graph. Now let's use blue color to graph the transformation. So this is the transformation. So we have 3 types of transformation here. We have horizontal shifting. So this is pushing this graph to the left 2 units because it's x plus 2. X plus 2 shifting the graph, every point on this graph to the left 2 units. And basically we want to work with these 3 points, -1, comma 1, 0, comma 0, 1, comma 1. So when we push the graph to the left, so we need to graph this -2. Push this point horizontally 2 units to the left, we'll get this point. So now we see the vertex, and we call this point vertex, -2, comma 0. Right? This is 1, comma 1 point. Well, 1 minus 2, 1 minus, because we're pushing to the left. So 1 minus 2 get -1. So this point being pushed to be this point. To be this point. So that means this, you see this red branch being pushed to the blue color. And same thing here, this point was -1, comma 1. -2 to the other side, it becomes -3, +1. So being pushed here. Okay. So this becomes -3, 1, +1. So working with these 3 points. And each one we subtract that x value by -2. Subtract by 2. Because we're pushing the graph to the left. Even this is a plus. Don't get confused with this plus sign, all right? We're pushing to the left. Okay, so now, so this is a horizontal shifting. Now the second step, we're going to do this reflection. Let's use green color. Right, we have this dilation or reflection. because this is a -1. This means every absolute value becomes negative now. Only the 0, 0 or this vertex doesn't change. So this changes. Okay, I should do this. I should do one more step. So blue color is absolute value of x plus 2. Now we want to graph a green color. Green color will be negative absolute value of x plus 2. Right, so every point be negate, especially the y value, the function value. But the 0 negate 0, we still get 0. So we still get this point, the vertex. But this positive one, negative positive one becomes a -1. So let's see, this is a -1. So now this point reflect over becomes this point. And this point reflect over becomes this point. Now we have this. So this is a negative absolute value of x plus 2. Right? And what is this point? This point is a -3, -1. You see, x value don't change. We don't change the x value. The x value doesn't get changed. It's the evaluation of negative absolute value of x plus 2 gets changed. So -3, we can do this. If x is -3, -3 plus 2, -1, absolute value of -1 is +1. But we have this negative sign outside, so get -1. So get -3, -1 point. And what about this point? This point is -1, -1. Because same thing. If x equals to -1, -1 plus 2, +1, absolute value of +1 is still 1, then we have this negative. So get -1, -1. Now, lastly, let's graph with maybe purple color. Now we want to graph the whole thing. We want to add 3. We want to add 3 to this green one. So adding 3 is adding the y value, the function value. So -2, 0 now becomes -2, 3. So let's see, this is 2, this is 3. So -2, 3. So that's this point. So the vertex being pushed up 3 units. Every point, the 3 points, every point being pushed up 3 units. So this point becomes -2. The x value doesn't change, but the y value is 3 now. About this point is -3, -1. -1 plus 3 becomes +2. So this point now becomes this point. Okay, this point is -2, +2. This is 2. What about this point? This point was a -1, -1, -1 plus 3, -1, +2. So that's this point. So this point is -1, +2. All right, so we can graph. The final graph, so this is the final graph of g of x, which is a negative absolute value of x plus 2, then +3. So the order is we do the horizontal shifting first, then we do a reflection, then in the end, we do the vertical shifting. Let's see B. B, we want to use x squared. So let's graph down here. We could also use 3 points. 1, 1, -1 also, 1. Right, but remember the parabola looks roundish. So this is a graph of x squared. And we want to use this one to graph G. G is x minus 2 squared plus 3. So let's graph x minus 2 squared, horizontal shifting. Let's use blue color. So we pick these 3 points to work with. Now 0, 0, x minus 2 will push into the right. So let's see, this is 2, this is 1. So 0, 0 now becomes 0, 2, becomes this point. Because 2, 0, not 2, 0, 2, 2, 0. Because this is horizontal changing. Horizontal changing is changing the x value. Then this point was -1, 1. Because -1 squared is 1, right? Now -1 plus 2. So when this is subtraction, we plus 2. -1 plus 2 become +1. So it becomes this point. This point is 1, 1. Now, what about this one? What about 1, 1 point? 1, 1 point, 1 plus 2 becomes 3. Becomes 3, 1 now. And this point is 1, 1. So now the graph looks like this. So this is the graph of x minus 2 squared. We see x value being added 2 units. -1 plus 2 becomes 1. And 1 plus 2 becomes 3. Okay, then we have a vertical shifting 3 units. So let's graph with green color. So we'll push those 3 points, we'll push every point on the parabola 3 units up. So let's see, this is 1, 2, 3. Let's see, this is 3, right? So 2, 0 now becomes 2, 3. So this is our vertex 2, 3. Because every y value, horizontal shifting is changing the function value or the y value. And this 1, 1 now becomes 1, 4. Let's see, maybe 4 is here. Become 1, 4. And this point 3, 1 now becomes 3, 4. Somewhere here. 3, 4. Now we can graph. So the graph goes like this. Roundish, right? Because it's a parabola. It's not a straight line. So the green color is the graph x minus 2 squared plus 3. So this steps up called transformation. So we transform horizontal, vertical, or maybe reflection. Now let's see C. C, let's grab this one first. Let's also grab with red color first. So the graph of this, you can always, if you don't remember the graph, right, it's better to remember the reference graph. All right, if you don't remember, just evaluate 3 points. If x is 0, just pick some easy x values. If x is 0, you get the function value to be 0. So you have this point. And 0 is the smallest number it can be, because we're in the real number world now. We don't consider complex numbers yet. And if x equals 1, square root of 1 is 1. So you get 1, 1 point. So let's see, this is 1. This is 1. Now the next one, you don't want to do square root 2. Right? Square root 2, square root 3. You want to do square root 4. So you want x to be 4. So if this is 2, 1, 2, 3, 4. So this is 4. Because we know square root of 4 is 2. Let's see, this is 2. So get this point. Except linear functions, other functions, when we graph smoothly. Smoothly means roundish. Right? It keeps going. Smoothly means roundish. So this point is 4, 0. This point is 1, 1. And of course, we have the origin 0, 0. So this is a reference graph of square root of x. Now we want to use this to graph the transformation function 2 radical x plus 3 minus 2. Let's use the blue color. We always want to do the horizontal shifting first. X plus 3 because under the square root sign. X plus 3 is horizontal shifting. Plus 3 means we push everything to the left 3 units. So this is -1, -2, -3. So now 0, 0 being pushed to -3, 0. And then 1, 1, 1 minus 3, that's -2, -2, 1. So at this point. Then 4 minus 3, that's just 1. So we have this point, 1, 2. So our graph looks like this, not straight, smoothly, roundish. So this is the graph of square root of x plus 3. You can always give some easy values to see it, right? If x is 1, we get square root 4, which is 2. If x is 1, so my graph is not so good, right? Because if x is 1, square root of 4 is 2. Should be somewhere here. Okay. So, but we want to graph by transformation. So square root of x plus 3, so we say x plus 3, that's horizontal change. Now let's do this dilation, 2. So it means the square root of x plus 3, the value of y value or the function value be multiplied by 2. Well, -3, 0, 0 times 2 is still 0. So we still have this point. Let's graph with green color. So we still have this point, right? Because 0 times 2 is still 0. And then we have this 1, 2 point. There's 1, 2 point from the blue color. Let's write in blue color first. We have this. Oh, hold on a second. 1, 2 is this point. But this is -1. -1, that's square root 2. We don't want to do that point. We want to do -2. -2 is 1. So let's do this point. -2, 1 point is much easier because x is -2. -2 plus 3, that's 1. Square root 1 is 1. -2, 1. And then this is 1, 2. Because x is 1, 1 plus 3, that's 4. Square root of 4 is 2. So let's work with these 3 points. Okay, -2, 1 point becomes -2, 2 now. So -2 is here, 2 is here. Right. So this is -2, 2, because 1 times 2 is 2. 1, 2 now becomes 1, 4. So let's see this 3, 4 somewhere here. So this because of this dilation of 2 times the y value, the function value. Now we have these 3 points. So the graph looks like this. Okay, so the green color is a graph of 2 radical x plus 3. Now in the end, we'll have a -2. Let's use the purple color. So purple color, so minus the y value by -2. Let's see this -2. Let's see this -3, 0. 0 minus 2 is -2. So this is -1. This probably -2. So this point now becomes this point. -3, -2. Because this point being pushed down 2 units because it's subtracting 2. Pushing down 2 units. So it becomes -3, -2. -2, 2. 2 minus 2 is 0. So -2. -2 here, -2, so that becomes this point, -2, 0. Then the third point is 1, 4. 4 minus 2 is 2, so 1, 2. 1, 2 is this point. So the graph is now like this. So the purple color is the final graph of 2 of square root of x plus 3 minus 2. Minus 2 is outside the square root sign. Plus 3 is inside the square root sign. So that's why plus 3 is a horizontal shifting to the left. Minus 2 is a vertical shifting down. And 2 is a scaling of the square root value. So we want to do horizontal shifting first, then the scaling, the dilation second, then the vertical shifting last. Okay, lastly, we have this D. We want to use x cubed to graph half of x cubed plus 4. Let's see if we can do here. Let's do red color first. So x cubed graph, you can also use 3 points. If it's a -1, we get -1, right? So this is a -1, this is a -1, so we'll get this point. And if it's 0, it's a 0, because 0 cubed is still 0. -1 raised by 3 is still -1. And positive 1. Positive 1 raised by 3, positive, still positive. So have these 3 points. But that looks like that on the line. No, we don't want to graph there on the same line. We want to graph smoothly. And the shape looks like this. Then wiggles at the origin. All right. So this is the shape. So the shape is like this. All right. It wiggles at the origin. Okay, we still pick 3 points to work with. Then this one, we don't have a horizontal shifting because x doesn't minus anything or does add something. Well, you can see x is just plus 0 minus 0, right? You just have to apply the scaling, the dilation half, right? So half, so that means each y value being halved. Now -1, 1 becomes a negative, oh no, -1 becomes a -1, -1/2. So the point reaching to be blue color. -1.5. So the point becomes here now. And then 1, the point is here now. 0 times half is still 0. So the graph looks like this. Okay. So this is the graph of a half x cubed. Plus 4 will push the 3 units up 4 units. Okay. So this point was 1, and this point was -1, -1/2, -1/2, or 0 still 0, still at the origin. Now we want to add 4 to the y value. Right, add 4 to the y value. Let me change it to be purple color. So let's do the origin one first. 0, 0. Now the second 0 plus 4 is 4. So 0, 4. So this is 1, 2, 3, 4. So we have a point here. This is 0, 4. And then we have 1, half plus 4 is 1.5. So 1, so it's somewhere here. 1, 4.5. And this one, -1, -1/2. 4 plus -1/2, 4 minus half, 3.5. So 3.5 somewhere here. So this one we're going to -1, 3.5. So get these 3 points. We're going to graph the same way, smoothly, and the wiggles at x-axis. So this is the graph of G here, half of x cubed plus 4. Okay, that's a graph that uses reference graph and apply transformation.